Hey guys, it's Srinivas again. Welcome back to the second video. So now we'll be going through some common question types that are frequently featured in the DSE paper 1. So here you can see a very standard question. It is about making a variable the subject of the formula. These two questions are actually very similar. It's just that this requires one more step of bringing the 2 and 3 to the other side. So let's try out 2019. So the first thing is just to expand the 9 into both things inside. So if we have 9h plus 6k, we bring the 9 to both of these. So 9h plus 9 times 6, 54k. And on the other side we have 7h plus 8. So the next thing to do would be to bring h's, all the h's into one side. So we bring the 7h to the other side and we have subtraction. So we end up with 2h. And we bring this to the other side, we have 8 minus 54k. And the next thing to do would be to get rid of the 2 and divide both of these things by 2. So we have 4 minus 54 minus divided by 2, which is 27. And that is it. So now we have h alone, and that is what they're asking us. So here is a very common factorization question. So in 2019A, they're asking us to simplify this. And here we identify that it looks very similar to this common identity, a squared minus b squared equals to a minus b, a plus b. So we first try to make this more like a squared minus b squared. So we take the square root of 4m squared, we have 2m, and square root of 9 is 3. So we're able to find out that the answer would be a minus b, a plus b, where a is 2m and b is 3. And so moving on, this question is similar, but first you have to take away the n, because there's n common in each of these terms. So once you've done that, you're left with 2m squared plus 7m minus 15 on the inside. This is when you have to use the cross method, and you see that you make one of them have 2m, the other one is m, and on this side you have to choose them accordingly so that the cross product of 2m times 5 minus 3 times m is equal to what's in the middle. So here we have 2m times 5, which is 10m, and minus 3 times m, which is negative 3m. So 10m minus 3m is 7m. This checks out. So we realize that the answer to this is just n, 2m minus 3, m plus 5. As shown over here, 2m minus 3, m plus 5. These two gives you the answer right away. So okay, the last part, it looks really hard, but actually it's really just a combination of these two first steps. So once you got these done, this is actually much easier. So we realize that 4m squared minus 9 is also present over here. So we already know the answer to that, which is 2m minus 3 and 2 times 2m plus 3. Here we have negative 2m squared n minus 7mn plus 15n. These two are very similar, but the only difference is that this is multiplied by negative 1. So if you move the negative 1 out, we end up with the same thing. So if you can see that this thing is identical to this, and so we have the answer for the simplified version of this, which is over here. So now all we have to do is realize that these two are now common again, 2m minus 3 and 2m minus 3. And we can just take that out, and we are left with the final solution, which is 2m minus 3. And on the outside and on the inside we have 2m plus 3 over here and negative 9 m plus 5. And I feel like it's really simple if you do these two first and see how they could be used in the final question. So here we have compound inequality questions, and these can be very much solved like regular equations. So here we take the 4 to the other side and we're left with 8, and to expand the bracket we just have to multiply 8 to both of these two things. We have 8 times 3, which is 24, So 24x and minus 8 times 1, which is negative 8. So now we have this very nice equation, a very nice inequality here. We can just take the x's together and the coefficients on the other, and the constants on the other side. So we have 26 plus 8, which is 34, and on the right side we have 24x minus 7x. And we're left with 17x. So now we just divide both sides by 2. We have x is greater than or equal to 2. And to illustrate this more nicely, we can do the other way and say x is greater than or equal. We can just switch it so it's a nicer format. So the next part of the question is we need to find the number of integers satisfying both these two things. So we've done this, but we also have to do this, and this will sometimes people skip these steps, but you have to also solve these steps for this. So very simply, we take the 5x to the other side, and we have 45 is greater than or equal to 5x, and divide both sides by 5. We are left with 9 is greater than or equal to x, or in other words, x is smaller than or equal to 9. So with these two things, we want to find out how many integers are between these two. So it's very simply, you can count starting from 2 all the way to 9, and if you count this, you have 8. Or a faster technique would be to just calculate 9 minus 2 plus 1. If it's like a large set of integers, using this formula, you can find the answer very quickly. So 9 minus 2, 7, plus 1 is 8. That's another way to do it. So this is a percentage change question, and we want to find the marked price for question 5a. So we let x be the marked price, and the marked price is simply the original price without any changes, without any discounts. It's what's written on the item itself. So we want to find what the marked price is, and the discount is said to be 25%. So that means, we have the original price, which is, let's say, 1, and we have subtract 25% out of that. That's why we do 1 minus 25%. And if we multiply this percentage to x, we will end up with the selling price, which is 690. And so now we have the equation set up. If we do simple arithmetic, we can get the answer. So 1 minus 25% is 0.75. So 0.75x equals to 690. And using the calculator, we get x equals to $920. That's how we find the marked price. So now the next part of the question is, after selling the wallet, the percentage profit is 15%. So the concept of percentage profit is very simple. Percentage profit is simply the profit divided by the cost. So it's like if you earned $20, but if you had to invest $1,000 into it, it's not very significant. That's why the percentage profit will be very low. So it's simply the profit over the cost, and the profit is what you earned. So it's what you sold, which is 690, minus what you paid to get it. In this case, we're using y as the variable to be the cost. So we let y be the cost, and also so we have 690 minus y divided by y times 100% equals to 15%. We can bring the y to the other side, so make it more nicer. So we have 15%, which is 0.15. So we have 0.15y equals to 690 minus y. The 100% can be ignored because it doesn't change anything. 100% is 100 over 100 and equals to 1. So now we're left with this. Again, it's just simple arithmetic. So we bring the negative y to the other side. We have 0.15y plus y, which is 1.15y. And we end up with y equals to 600. So that tells us the cost of the wallet. One important thing to note is that the profit can also be a negative. So if we have a negative profit, let's say you lost $20 while you're selling the product, then you'll also end up with a negative percentage profit. Since they gave us a positive number, we don't need to worry about the negative in this case. So the question entails, if there are 21 boys and 11 girls in a class, and a committee consists of 5 students from the class, then how many committees can be formed? So they're asking specifically of how many committees can be formed with at least one boy. And to find out this, so first we were finding the total number of combinations without any conditions involved. So we have 32 students in the class because there's 21 boys and 11 girls. If we add them up, we get 32. And from that people in the class, we are choosing 5 students. So we have 5 on the bottom. Hence we left with C 32 5. Next, we want to find out how many committees there are with at least one boy. But instead, we can do it faster by finding out the committees with no boys and simply subtracting that from the total. So for here, we have 2 things to multiply together: the number of combinations for the boys and the number of combinations for the girls. For the boys, since we already said we're having no boys here, the number on the bottom is 0, and on the top is 21. And for girls, it's 5 because if we have 5 students in the committee and there are 0 boys, there's definitely 5 girls. So, and there's also 11 students and 11 girls in the class. So in the top we have 11. So in order to calculate this, we realize that C21 0, even though it looks hard, since it has a 0 on the bottom, it must be 1. It's a simple rule you can use to shorten your answer. And now you end up with C11 5 for the answer for the committees with no boys. So finally, we can just subtract these 2 things to get our final answer. Just a little tip: if you have a weak foundation in maths, I suggest you do all the questions in A1 and A2 first before attempting section B. So if you have any other questions, follow us on IG and shoot us a DM. Otherwise, that's it for me, and best of luck for your DSE exam. Bye guys!